Welcome to Chapter 9 class. We're going to look at the basic between subjects designs and what it looks like to engage with placing our um, participants in different experimental conditions. So, the purpose of an experimental design is that the design of an experiment details the experiment's plan for how they're going to test their hypothesis and look at the impacts of the causal relationship between their two variables. The design is the experiment's structure, the floor plan, and the specific content that is going to be involved with testing their variables. We can use the same design to investigate different hypotheses to get a outcome. The experimental design is largely determined by the hypothesis of the experiment. So researchers mainly select experimental designs based on three factors. Number one, the number of independent variables that have been hypothesized within the research question, the number of treatment conditions needed to test the hypothesis accurately, and whether the same subjects are used in each treatment conditions across the board. So in between subject designs, the subject participates in only one of the conditions that are within the experiments. We have to make sure that our representativeness of our sample determines whether we can actually generalize our results to the general population from the sample that we created from the general population. So we talked earlier about random sampling. This is um, um, a type of sampling that will definitely increase the external validity of our experiment. And so, randomly allowing people to conveniently be a part of the study and give everyone within that criteria, of course, or everyone, if we're just doing males versus females, giving them the opportunity to be a part of the um, experiment can broaden um, our ability to represent the general population, thus increasing our external validity. So, in order to effectively do this, you should have at least 10 to 20 subjects in each treatment condition that you are implementing to detect a strong treatment effect. So, when we talk about treatment conditions, again, we're talking about say the experimental group versus the control group, the group that gets the actual experiment versus the group that gets the placebo. Fewer subjects in each condition risk not detecting the effects of the IV on the DV because we are limiting the amounts of observations to see whether or not if that effect is going to occur. So the effect size in a statistical estimate of the size or magnitude of a treatment effect is highly important to um, the methodology section or the data analysis section, if you will, when you're implementing the measurements of your study. The larger the effect size, the stronger the relationship between the IV and the DV may be, and fewer subjects can be needed to detect treatment effects if we have a significant effect size within the experiment. Effect size is going to determine the number of subjects required to detect a treatment effect. And so researchers will determine the number of subjects required for an expected effective size by using power charts or programs that incorporate these charts to indicate um, the level of effect size that's needed for the experiment. A two-group design is going to involve the creation of two separate groups of subjects, and two versions of the two group designs are the two independent groups, and we take those two independent groups and match them with the group design. So let's look at the differences again between the conditions. So the experimental condition again represents a value of the independent variable, which means my independent variable may be a happy pill. And so I'm going to take that happy pill and see how um, it is impacted on my DV. Now, my second condition will be the control condition, and this represents um, a zero level of the independent variable because this particular group has no impact, no effects. It is the placebo group. So I want you all to remember this as you're setting up your presentation, your experiment, because you have to be able to identify what those treatment conditions look like in the methodology section. So what are you going to apply in the experimental condition that is not going to be applied in the comparison group, which is the control group, as it pertains to its effectiveness on the DV. This describes a two independent groups design. The experimental group receives a level of the IV, and the control group receives the same procedures but receives no treatment at all. Matching is used to create groups that are equivalent on potentially confounding subject variables. So, successfully matching prevents selection threat from undermining your internal validity. We need to ensure that we measure and predict any extraneous variables as we've talked about before. We need to measure an extraneous variable, strongly correlate the dependent variable so that we could control some of those confounding results that may occur. So we want to engage in practical limitations within the study, and this includes paying attention to available subjects, trying to determine whether or not we have time, as well as how expensive some of these procedures will be in order for us to engage in um, a number of treatments or treatment conditions. Will there be enough people to participate? Will we have time to effectively engage in these treatment conditions? And how expensive will the materials be for participants to engage in those treatment conditions? What is always helpful is a pilot study, and this is specifically like a trial run of the experiment, and it uses a fewer subjects, but it allows us to kind of gauge where we're going to or how we're going to conduct our experiment, and then also see if it's even worth the time. Um, or the expenses, etc., as it pertains to a particular experimental idea that you have or that you want to test. A pilot study can help the experimenter refine the procedure section and determine whether or not they see promise in that study. Here are some of the things that a pilot study can reveal. You can allocate sufficient time, whether or not your instructions are clear and whether or not you need to go back and redefine that, whether or not your deception in ensuring that there are no experimental bias present and that the participants don't understand exactly what it is that you're doing, so then it kind of skews the data. um, you want to see if deception works. And then additionally, you need whether or not you'll need additional treatment conditions to measure um, the effects of your IV on your DV. Okay, so that is going to conclude this chapter lecture, and I will see you in the next one.